starter, we're going to learn a little bit more about the field of engineering tonight. What you can expect from the presentation this evening is a brief introduction to the world of engineering, specifically as discussed by our 4 professionals who are in the field. Then we'll get into resources of how all of you students can continue your career exploration after tonight. I've got some great tips and tricks for you to take home with you. And then we'll end the evening with a drawing for a $500 scholarship and this giant check. So if anybody has their scholarship ticket left, please go ahead and put it in the jar over on that blue table. Okay. Yep. Let's jump right into what engineering is. I love this quote from Albert Einstein, that scientists investigate that which already is, and engineers create that which has never been. So when you think of engineering, hopefully you think of things like problem solving, probably a lot of math and science, and we'll look at different fields of engineering once the panelists are up here. One thing I wanted to bring to your attention is that Michigan is one of the top 10 states in which engineers are employed. So we're in a good spot. And I'd like to start right away by welcoming our panelists. First up, we have John Francis, who's joining us from Ford Motor Company.
Again, my name is John Francis, engineering team manager at Ford Motor Company. I didn't start out to be an engineer. It's not what I started to do. I was a mechanic, and that's how I started my career at Ford Motor Company. And went to college. Ford paid for my degree, and I currently work at the Romeo Engine Plant as their manufacturing engineering team manager. I have several different disciplines that I'm responsible for: electrical, mechanical, industrial, tooling, test, etc. Mechanical engineer is what I graduated with, so I look forward to tonight, and any questions, please feel free to ask as we go on. Thanks.
Yes, thanks for mentioning that. So we have an incentive to ask questions in the form of candy. So parents and students alike, please ask your questions. Next up, Lindsay.
Hi everyone, my name is Lindsay. I am a mechanical engineering student, and I currently go to Saginaw Valley State University. I'm a senior right now, so I'll be graduating in a little over a year. So I can tell you a little bit more about what being an engineering student is like and kind of what day-to-day college life is for you guys.
Hi, I'm Bob Van Til, professor at Oakland University, Industrial Systems Engineering. Didn't want to start out as an engineer. In high school, I was going to be a teacher, history, geography. Senior year, teaching market is like in the mid-70s. There is no jobs anywhere. Sitting on the ACT, well, what can I do for my life? Business, I don't know what they do, looking down the list and like, oh, engineering, that sounds interesting. I could put a job to that. Checked it off. Went on to Michigan State, got a degree. Worked at General Motors all along the way and decided I don't want to do this for my whole life. I want to teach. And so I went on to Northwestern, got a graduate degree. Worked a little bit more with Northrop Corporation. Decided, no, I really do want to teach. And so I ended up back in teaching engineering. So one thing to, if you have that path in mind, one thing to warn you about, keep up with your math. Because I spent my whole first year making up all the math that I should have been taking in high school before I get to read the college level stuff. But you got a lot of flexibility. There's a lot of different ways you can go with that degree in engineering.
How's it going, everyone? My name is Austin Linsky. I just a recent grad from Michigan. I studied aerospace engineering. And now I work at a company called General Dynamics Land Systems. They make military vehicles for the Army, the Marines, and other branches around the world. I can give you a little insight today on kind of a new hire in the engineering world, what it's like to be the youngest person that you work for. So yeah, if you have any questions, feel free to ask.
Okay, you'll notice I use my engineering brain. It's very small. And place the panelists in order on the screen. So if you have questions, feel free to use their name and direct your questions to specific people or to the panel as a whole. All right, if we'd like to start with a typical day in your life, John, what does it look like at Ford Motor Company?
I do a lot of hiring of people, young engineers, old engineers, but I don't want to say there's a lot of turnover, but I'm an old guy now, right? So there's a lot of people retiring, so I'm bringing in a lot of new people. And I think a day in the life that when you're going to engineering that I didn't expect is you have to be a people person, right? You have to, so being able, there's engineers that can sit behind a computer or in a research area, and that's what they do all day. I work in manufacturing environment, and I have to be a people person. I have to interface with other people. And I think that that's probably what a major part of my day is. Obviously, I'm in a management position, but for me, it's about dealing with people. It's about interacting with people. It's about teamwork. Engineers, as much as we like to think we do great things all on our own, we do our best work in teams as people. So at Ford, in my day-to-day thing, that's what it is. It's about continual teamwork and just continuous improvement, right? And dealing with people. I deal a lot with people, and I'm going to tell a story about an engineer that we hired that didn't end up staying with our company, and it's for the young people. I'm an old guy, okay? So this engineer came in, and he had come in through recruiting. I didn't hire him in, and when he came in, we were doing our intake, and we were talking to him, and we had me and two other supervisors there, and another engineer that was going to be his mentor. And he didn't bring first of all, I'm an old guy, again, he didn't bring a piece of paper and a pencil with him, or pen. So what he did do is he sat there on his phone the whole time, and he never looked up. So I tell him what he was going to do, and he never looked up at me, not one single time. And he sat on his phone the whole time. So about halfway through the meeting, I asked him what he was doing on his phone. He took all of his notes on his phone. So whenever I would ask this person something, he would look up on his phone, and he'd give me the answer on his phone. So it's a generational gap for me that I have to overcome, but also it's that people side of the business that we need to be able to converse with one another and talk to one another. So I'm in a huge learning curve right now in my job with the young 20-year-olds that are coming in to the business, and it's definitely a little bit different of a landscape.
Yeah, actually, I'd like to get a feel for the age group that we have in the crowd. If you're a student, if you could please raise your hand if you're in 12th grade. Grade 11, 10th, 9th, anything younger than 9th grade? Okay, thank you.
Yeah, a typical day for me normally starts out with hitting the snooze button. So, yeah, after a late night study. Yeah, but then I make my cup of coffee, get ready, and go to class. Classes at Saginaw Valley are typically about 30 students. Unless you have a lab for that class, then it's a little bit less. Yeah, but it's really nice because you can pick your schedule, so all of my classes start at 10 o'clock right now. 8:30s are doable, but I would not recommend it if you can avoid them. Yeah, so after my classes, I normally do a bit of studying. I'm also involved with some organizations on my campus. So like my first couple of years, we have a movie club. So they put on free DVD theater movies. So an example of that would be the Grinch movie that's out now. They'll be showing that in the springtime before it hits DVD. So we put spring movies on and popcorn and stuff like that, and then there's also different programming boards and stuff like that. And then I'm also involved with the Society of Women Engineers, which is a professional group on campus. It's also a nationally recognized group. So we bring in all these female engineers together, and men can join too, but it's a really good place to try and get collaboration going and a sense of finding a peer group. Yeah, so I'm the president of that, so I try to plan all the meetings out and do that. And then I study a lot too, because college is hard.
So I'm coming at it from very different because I'm not like the typical day because I'm not a working engineer. I'm a pseudo-engineer teaching. And so, but what I do is deal with our students and getting them from that high school to that engineering profession. We're the people who bridge through. A lot of changes going on. We're lucky at Oakland because we're sitting within a 50-mile radius of 3,000 engineering and manufacturing companies. And so our program is organically developed over the years. My program is 10 years old. Industrial Systems Engineering is a new program at Oakland. The university goes back to 57. Engineering school to the early 60s. Mechanical, electrical, computer engineering, computer science. We're 10 years old in our program, Industrial Systems. It's the nightmare marketing name. Everybody hears the name industrial. And your first thought is, I'm going to be in an auto plant building cars all day. That sounds pretty boring. I don't want to do that. Not. Those are business students in operations. They're building cars all day. Industrial engineers would build the auto plants. They build manufacturing systems. That's the name industrial. So you got this big complex system that stuff flows through. And they look at how to flow stuff through that system. The and systems part comes out from the fact that supply chains and hospitals and places like Disney flow a lot of stuff through them. And so industrial engineers will work at hospitals. They'll work. I got a student at Disney. I have interns at Disney working. They're very large hirer of industrial engineers. Real fun job. Aerospace, all different domains, and that's where the and systems part comes in. I have a senior design team this semester working at Crittenden Hospital and at Comerica Bank. The stuff that flows through the system doesn't have to be physical, it can be information. And that's what's going on at Comerica. We're looking at how information flows through and how to improve the flow of that information. And so the industrial, it's working with our students organically because of all this industry in our area. Most of our students take 5 years to graduate. And the reason why, by sophomore year, most of them are interning year round. And this is not free interning. 4 years ago when I kind of surveyed my students, it was $16 to $25 an hour 4 years ago to intern. As many hours as you want, as you can fit in. And so a lot of our students will take 3 classes a semester, work full-time in the summer, 2 or 3 different companies along the way. They will start their full-time jobs senior year. Last year when we held our monthly student, faculty, staff lunch with all our students, let's all get together. And once a month we do this. Company sponsors at Siemens came in and said, hey, give us your top 10 students. Talk to them. It's like, oh, I'm not looking for a job. I'm already working full-time. I have my full-time job at GM or FCA. And it's the start of your senior year. Oh yeah, once I graduate at the end of the year, they're giving me all the time off I need to finish, and then they'll give me my official title at the end of the year. So it's a huge domain, and all domains of engineering are like this right now. It's a good time to go in. Way more demand than supply, but it's changing. If you do go in, make sure you get the internships, get the real world experience. That whole picture is changing in the old days versus just the academic side. Jump over the wall, do the real work, jump back into the academic side. It's all getting merged together now, and it's producing really good students because of that.
Awesome. What is it like at General Dynamics?
So for me at General Dynamics, like John was saying, there's a lot of people that are retiring now, so they're bringing a lot of new people in. So I'm kind of one of those new guys that brought to the company. For me, when I first started in, I was the youngest person, I think, at the company, and all the people there could have been the same age as my father. So it's kind of this weird relationship where it's like you're almost working with your dad in some cases, where they're a lot more knowledgeable, but you're the kind of the young kid coming in where you may know new skills that they don't know, but you work with them and interact with them in a way where, hey, I know this now, and you basically exchange information, like John was saying. Like, they can be really helpful for young people to come and reinvigorate the building, because a lot of people get set in their ways, and they might do the same thing over and over again because it's just that's what they've done for the past 10 years. So bringing a new person in can obviously change the dynamic of the workplace, and now we have 2 other younger guys as well working, and it seems like the place is a little more lively. There's a lot more jokes, a lot of people more talking. It's more like, I think there's more communication between people in a different way than it was before. People used to just kind of sit, send emails, and now it's kind of evolved to more people are talking to each other, and it just seems more lively. So for me, a typical day, so when I started working on electric vehicles for the military, so I helped when I made a cooling system. So basically a test bed where we put on a big dyno, so it's a big machine that basically spins the wheels of this big vehicle, basically to test how our system worked. And so I designed that cooling system to basically cool electronics. So electronics get hot when operating, so it pumps cooled water through and basically brings the temperature down into safe operating temperature. And then I kind of moved it over and shifted to robotics. So for about a year I was working on drones. So what we did is we first started, we just got like a classic frame. It's a hexacopter, so it has 6 motors, and we bought some COTS parts, which means just common off the shelf. So you can go online and order these parts that we purchase. And kind of built our way up to going buying military-grade gimbals and military-grade communication radios to kind of develop this system. So when we go to talk to other companies, since we're a military vehicle company, we don't really have intentions of building drones. So or more knowledgeable to say, hey, if a company offers a product, we can kind of say, hey, that doesn't seem too right. We want to look at the numbers again to make sure what they're actually offering is the real deal rather than just kind of just trying to get business. And right now what I'm working on is I'm designing a test bed for our company. So what I'm doing right now is a lot of research. So what we want to do is make a test bed that collects autonomous vehicle sensor information and just stores it. We're not going to have any autonomous capabilities yet. It's just more the starting groundwork of building a vehicle for the military that brings all this information in. It can store up to about 40 terabytes a day of information. So your average movie is a couple gigabytes. And so if you multiply a gigabyte by 1,000, you get a terabyte. So imagine having, how many movies is that, like 20,000 movies storing on a vehicle. It's a lot of information. So right now I'm researching a bunch of different sensors and how that all works together and developing a system architecture and basically making my own schedule to get people to work. So it's an ever-changing day for me. I'm learning a lot, and sometimes I get thrown to the fire, but it's kind of a good thing because you got to build to learn and adapt to the situations that are provided. So it's kind of my average day.
Who can tell me the name of the professional organization that Lindsay is the president of, the Saginaw Valley State? Very good. Society of Women Engineers, SWE. Sweet. What about the six-motored drone? What was the name of that Austin worked on? I had to write it down because I wasn't
tough.
sure.
She is tough. I don't know.
This is for the good candy. A hexacopter.
Can I ask one?
Yes, please.
What's the oldest domain of engineering? Anybody? The oldest domain of engineering. There's a lot of domains. Mechanical, chemical.
Environmental?
Environmental? No? Anybody?
Is it mechanical?
No? That's a common answer right there. That's the real common answer is mechanical. Think back to the Egyptians
I think somebody
and what
said
they
it
did.
back there. Civil engineering?
Civil engineering. I mean, the pyramids, the roads, the Greeks, the Romans, all that. That's all civil engineering. It goes a long way back. The other domains tend to be much newer. Civil is one of the main domains in I was asked to give you guys this little information because I do it on a regular basis on describing what industrial engineering is and comparing it to the other fields. The main domains of engineering in the United States are four main domains. There's the mechanical engineers, civil engineers, the electrical engineers, and the industrial systems engineers. There's about 300,000 of each of those working throughout the United States. Then it takes a little jump down to about 80,000 aerospace and computer engineers, and then the chemical engineers and the nuclear and all the specialty bioengineers start to peter down from there to a little bit smaller. All domains of engineering are really are pretty solid. You will find demand in all the domains. Michigan, we're known as what? An ME state, 40,000.
What's ME?
Mechanical. Sorry, ME. Us engineers do that. We're MEs, we're double E's, we're ISEs, we're CEs. We do that. About 40,000 mechanicals, about 28,000 industrial engineers, about 12,000 electrical engineers, about 5,000 civil engineers, and then it peters down from there. So we're a heavy, with our manufacturing base, we're heavy ME and industrial engineering with a big dose of electrical.
When you mentioned civil engineering, I wasn't really thinking about that when we talked about women's engineering. I hear a lot of mechanical building things. So if civil engineering would be a direction somebody wanted to go into, what would the major study be? All the same courses?
Roughly, through accreditation, the basic front end of most engineering programs are the same. It's 4 years of calculus, 4 courses in calculus, 2 in physics, 1 in chemistry, usually an elective course in science. They require basically 32 credits worth of math and science. And that goes by accreditation, that goes across all engineering domains. It's a general accreditation requirement. So you see that in all the math, the engineering programs. They'll vary a little bit between this calculus course and that calculus course, but they're roughly that. They'll sneak in a few special courses, but in any of the engineering majors, you will be there as a civil engineer in that program, and you'll be doing junior and senior level coursework specializing on that. A little bit freshman, sophomore stuff, but that's more the prep work.
So what types of courses are there?
In civil engineering, you're talking about building roads, surveying, building construction, infrastructure, So they're the people who are building the freeways and design, not necessarily building them, but the designing of the freeways, the layouts and surveying. And in large construction projects. Airports, large transportation projects, you know, the big bridge going to Canada, that type of stuff is civil engineering infrastructure. It is not a super major job in Michigan. Again, there's probably about 5,000 of them working compared to mechanicals, industrials, and electricals. But it's a domain that has strong growth, and you see that by just driving on the roads and driving the infrastructure we have in the U.S. That's like that everywhere. So it's predicted to be a strong domain because of the road systems.
I'd like to shift gears a little bit. Now that we know who is in our crowd, 9th, 10th, 11th, 12th graders, if you could think back, some of you further than others, to your high school days, and thinking what you wish you knew as a high school student. And it can be course related, it can be work ethic related. Go ahead,
This is
John.
me?
Yeah.
So I took a little bit different of a route. The only way that I passed my high school math courses is because my girlfriend sat next to me. That's the honest truth. And like I said, I wasn't in a position, and I guess I found a home in the auto shop, right? That's where I felt comfortable. I could do stuff with my hands. I knew how I could make stuff work. And I never even thought of a career in engineering because I knew that my parents couldn't send me to a college, but I didn't think that I could have gotten there on my own. So a little bit more self-motivation and a little bit, they didn't have these programs, at least I didn't go to these programs, 10 years ago when I graduated high school, just kidding. But a little bit more, if I really wanted to, I could have done it, and I just didn't do it. And I'm not saying that I didn't make the wrong choices. When I got into college, I did a 2-year degree at Macomb Community College, and that's where I learned to study. That's where I learned the rewards for the achievements in the educational system, et cetera, right? And, I think the thing that I learned more is the more work that I put into something, the better the result was going to be. So I graduated with like a 3.96 or something. Granted, it was a technology degree, but I got a 2-year degree. And I'm like, wow, I did really, really well in that. And so got hired into Ford, and that type of work ethic stuck with me because I paid for that college. I paid for that myself, right? And then when I did get into engineering school, that desire to succeed was still there, right? And I guess I learned at an early age that people weren't my mom wasn't gonna come do this for me. I had to do it on my own. And that's what I needed to do. I'm the one that made my success. Granted, I had a lot of people there. Ford Motor Company helped me out. They sent me to the University of Michigan. I bleed Ford blue because of that. But I'm the one that put the work in, right? And the more that you put into it, the better the result's going to be. I didn't have that in high school. I never saw those results, right? I didn't have somebody there pushing me.
Sometimes it takes a taste of success to want more of it, for sure. What about you, Lindsay? What do you wish your high school counselor would have told you? I was your high school counselor, by the way.
I graduated in 2015 from Memphis, so I kind of wish I would have known more about hands-on opportunities, and that I actually wanted to go into engineering. For a long time I wanted to be a pediatrician actually, but then going on school tours to different schools, I ended up going up at Michigan Tech, and I toured their biomedical program, which I thought was really cool because it was a way to help merge helping people with all this math and science that I was good at. So that was during my junior year, and it kind of shifted me into the engineering mindset. So I wish I would have known more about like the first robotics teams or like workshops that you can go to and learn different skills that are used for engineering, because we have engineering classes that teach that. We have a manufacturing class where you learn like the presses and the CNC machines and the drills and all of that stuff. So I wish I would have known a little bit beforehand what I was going to be getting my hands into.
So I went to high school back when they were first invented. Just brand new concept. Thing that, again, as I mentioned, I didn't really keep up on my aunt, and that set me back, but that shouldn't stop you. And it's just, hey, well, okay, that means I can't get into that calc course I need until I take these other 3 courses
It
first.
took me 9 semesters of math.
Yeah, I had to go spend that whole first year. It would have been convenient to be able to start farther when I was in college, but it was just, okay, well, I'm just going to have to do this. So you just do one at a time. Don't focus, don't, oh my God, it's so far away to the finish line. Just do the one in front of you and then do the next one and do the next one. That would have been nice. Nice things to do in high school is keep hands-on if you can. And traditionally, that's kind of the route to the engineer. You know, auto shop, design cars, play with that. But the other big route right now is digital. Computer programming, playing with stuff. Engineering is going digital. We're in Industry 4.0 right now. You know, the 4th industrial revolution is going on. Everything's moving into a digital domain. The Internet of Things is available to make data available, to make you be able to do a lot of different things. That skill is amazing. It's amazing how many companies say, if we'd only get our engineers to code a little bit. We don't want coders. We hire coders. We want engineers that are comfortable with writing small scripts of code to do stuff. Huge skill, that digital side. Something hands-on. And interface with people. Don't think you're going to be sitting there by yourself, working in a lab, nobody around.
Tell me if I'm wrong here, there are opportunities for those people who would rather not work with people.
You can, yeah, absolutely. You can go both ways.
You can
You're
find
a,
yourself a cubicle if you look at that.
yeah, you're a total, I don't want to deal with anybody. You can be off doing that. I got
Research.
John Katuna, one of my graduates a couple years ago, is down at GM doing 3-point simulation engineer. He's using some Industry 4.0 design tools to develop digital models of manufacturing plants. So all the work gets done on the computer before they buy the equipment. And so he spends most of his day on the computer doing stuff. He'll go out and visit the plants and talk with people, and you will, no matter what, deal with some people. Whereas Anthony, who graduated a couple years ago, he's going to be a CEO at 30. He's a real people guy. He's going to do stuff. He's in Chicago, strategic consulting with Deloitte & Touche. Total 100% people stuff. That's his job, walking out the door. I'm going to be a people guy. I want to go that way. Kimmy graduated 4 years ago. She was kind of a people skill, but she started at 4. Probably 80% tech, 20% people. Worked there for a while and said, I really miss working with people. She moved down to Disney, way over on the people side. Absolutely loved it. Worked in their costume shop, believe it or not. You know, the Mickey Mouse, Minnie Mouse costumes and all their uniforms and stuff. As an engineer, she was not, had nothing to do with costumes, it was an engineer. Totally, I can go, if you want to talk afterwards, it's a 10-minute story. I give the story of what she does down there in the costume shop. From that, she kind of got really into supply chain. She worked there for a couple of years, got into supply chain, moving stuff around. Think Amazon, UPS, the post office. I mean, those are big supply chains. They move stuff everywhere. They're unlike manufacturing systems. They work the same, but they just don't paint and weld and do stuff to the product along the way. They just move it around. And she really got excited about supply chain. She just started at Home Depot's corporate headquarters in Atlanta. Last week, moved over to the supply chain. That supply chain position came available there, and she moved into that. Having the people skills, being working with teams, being flexible, engineering gives you a lot of ways to go. You ended up just teaching and talking like me too, and doing nothing but talking.
Austin, what would you tell 16-year-old Austin?
Well, for one, I agree with Bob. Definitely learn how to code. Coding, I think, right now is like one of the most important skills or sub-skills you could have, because right now, like I said, I'm working on drones and changing like flight plan software and like the controls from the drones. And I've been teaching myself, but I obviously didn't know enough. So there was some catch-up time where I just had to sit and just Google stuff and struggle my way through learning how to write these basic scripts. But now I'm a little more comfortable in how it works, and I understand a little more of the syntax, and I really think that is one of the most important skills if you want to do anything. Really grasp that when you take a coding class at college. I think they require at least one now, I think. But I mean, I really think if you can, you have time in your schedule, definitely try to get as far as you can, because I think that it's like Bob said, it's going to just rapidly expand even more digital, and it's eventually just going to be you sitting on computers and doing simulations. So I think it's really helpful. And as well as when you're doing stuff, remember to be in the moment. Don't worry about other things. Just try to grasp information and try to apply it to a real life thing that you might work on in the future. For me, like today, I was looking at some lenses for our autonomous vehicle that we want to build, but there were some old math calculations that I don't remember how to do at all. They're just kind of gone. And I remember doing it, but I don't remember how to do it. So it was hard for me in college when they just say, do this math problems or just solve like this quadratic equation. Like, yeah, I mean, I can do it, but there's no really real world application that they explain to you. So I think if you can kind of place that in a real world sense, say, hey, if this is what I want to do, this relates to that, and that makes it more cement and firm in my mind, at least for me, because I can just solve a math problem and eventually it's just going to leave my head because it's not really interesting to me or it's not really important. It's just, you just look up some rules and you just kind of go and solve it. But if you actually can apply it to something that's meaningful, I think that kind of it sits with you more and you can retain it more. So I think that's I would say coding, and just try to be in the moment and try to apply when you're doing work to real life things. You can't apply everything, like you might just take a class and you're really interested and you're just kind of got to get through it and you might not apply it. But if you're really interested in something and you kind of look what you're going to do in your daily life in your future career and say, hey, these are some core important things. Like there might be a special math class or a fluids class or whatever you want to do in the future. Just try to grasp a few things that you think might be important, and that'll be really helpful.
So what I'm hearing you say is that you're using math now that you learned in high school.
Some math, and then so all the math in high school is a good base for how it goes. So a lot of stuff you learn in high school, like I took advanced math and I took the AP test, and a lot of stuff it's a very important base, and then you obviously becomes more and more advanced the farther you go. So yes, definitely it's important, but I think it's just more of learning how that, because like in every class you do math, basically it's always math. It all becomes to math. At the end of the day, you get a structures problem, it's all math. You get a fluid dynamics problem, it's all math. So it's all math.
So what happens if half our audience gets up and walks out right now? Are we in trouble?
No, I think math is a skill that anybody can learn. I think it just takes.
agree with
I think
that,
it just takes time. Like if you struggle through it, some people just don't inherently understand things. Like you're gonna have some classes in college where you're not gonna know anything. You're gonna struggle through it. You might not get a good grade, but you work through it and you earn the grade you earn. And I really think that's an important way to approach some problems.
In high school, I did really well in math, but I wasn't good at applying the math to problems. How do you, when you were in high school, did you apply the math really well to problems on your own, or do they do that when you start working as an engineer, or are you doing that in college, or when do you actually start applying the math?
I think it varies. I mean, you're always you're always in college. You're always applying the math you've learned because they try to set it up where you work on you approach classes. So you may take a structures class and they may cover some math topics that are important related to that class. They kind of structure, at least for me, they kind of go hand in hand. But you kind of forget how things sometimes work. So it kind of just comes up at certain points. Because my first couple months as an engineer, I wasn't really doing any math. I was kind of like picking out products, like helping build systems, making schedules. But now I'm going back and trying to reteach myself. So there's looking at lens formulas and like all the math I used to know how to do and like reading graphs, and now I'm trying to re-engineer, go back and make equations myself to basically say, hey, this is kind of the sweet spot we need for this camera. But cameras can be different. They can see really far, see really close, they have a wide field of view, a short field of view, and now I'm trying to figure out in certain applications, like if a vehicle needs to stop, needs to see at a certain range in front of it. So you have a certain spot, say 200 feet away, and the vehicle stops at 150 feet, so it gives you more time. So it takes time for the system to process that information. So I'm going through and looking at like physics equations to try to say, hey, for lenses I need this much distance, I obviously need a shorter field of view, and then basically back calculating. So I don't think in the time when I was going through high school or going through college, I really realized real world applications, because sometimes it's not about real world applications. Sometimes it's just this we need to learn, and they don't really divulge or go into detail on what it's necessarily used for because they don't have time. They have a curriculum they need to follow sometimes, and getting into all that detail is just, I think, is a lot of work that they sometimes don't have the opportunity to do.
Math is really the language of the engineer, and in the math courses you're learning the language. It's not about applying the language, it's about learning the language, and I know that frustrates a lot of people. What am I going to do with this? What am I going to do with this? Show me what we do with it. Once you learn the language in your first few years, which is why you take your calc in the first couple of years, you start getting into your upper level classes in engineering, you need to know the language to apply it. And the engineering courses are where you apply it. So now we started teaching you Newton's law. Oh, you know that differential equation you learned in Calc 3? This is where we apply it to describe how if I apply forces on a body, it's going to move around and accelerate. And so the engineering courses are, okay, now let's take those tools and apply them. And it can be really frustrating when you're in the math side. And I will hear that a lot of students like, well, show us how to apply it. And it's like, no, that's not their job. Their job is to teach you the tool, hopefully give you little peeks where it's going to go. Our job is then to use that, show you how to use that tool to do stuff.
When do you get into your engineering classes as opposed to your basic Calc 3 and other math classes?
When do you? Well, traditionally it would be year 3 and 4, historically. In the last 10, 15 years, there's been a real groundswell about losing retention going way down on engineering programs. Because you go in, I'm going to be an engineer, and you go calc, physics, thing, where the heck is the engineering? And then by being a freshman year, you're dropping a big ton. Into sophomore year, you're losing a lot. Into like 30% of the people never make it to the engineering classes. So in the last 10 years or so, there's been a big push to, well, how can we start to put some of the engineering stuff up front? But it's kind of limited because you don't have the tool set yet. And so we'll do some CAD stuff and some programming. You try to give some flavors of engineering up in the first couple of years. But it's primarily a math and science program the first couple of years before you really seriously get into the engineering.
Lindsay, does that mirror your experience at SCCRESA?
Yeah, so far we've done, like my first and second year, I did all my math classes and a couple gen eds and stuff. We have an MEEC 101 class where you actually take a Lego Mindstorm kit and you build this robot that follows a line and climbs a ramp, and then up at the top of the ramp you battle another robot that someone else in your class made, and whichever robot gets closest to the center wins. So that's kind of a really good introduction into a little bit about how to make things work, like with the gears and stuff. We also have a class that second year students take. It's our CAD class. So they're using 3D modeling with SolidWorks to learn the prints and stuff like that, in addition to the math classes that you're learning. And then once you get into more of the third and fourth year classes, that's when you really start applying those math problems and kind of learning different applications and when to use those.
So you all mentioned wishing you had maybe more hands-on experience at a younger age. I'd like to ask the crowd, can anybody think of opportunities that we have here in St. Clair County? Yeah.
The tech night?
Tech night?
Yeah, it's after school. It's a group of people that build robots and stuff.
Okay. How many people here are part of a robotics group? Okay. What about our tech center programs?
Yeah, question?
No, I was going to say, at our school we have First Robotics.
First robotics.
So,
Let's go.
I'll
What about our tech programs? Who can name a tech program that would be related to engineering?
Mechatronics.
Mechatronics. I've got a secret to tell you. It's being renamed.
I know, robotics now.
Oh, you already know. The robotics and engineering. So we have a mechatronics program at the tech center. Any other ones you can think of that might be related to the engineering field? Yeah.
Renewable energy.
Ooh, I wish that we had a renewable energy program, but that would be related. Not yet, hopefully in the future. We have,
I know at our school last year we got a new engineering class. It's the first year. It's called Intro to Engineering Design.
that's great. So at her school, they have a new class called Intro to Engineering Design. We're here on schools. And what grade level do you need to be in to take that? Oh, freshman year. We have an information technology program at Tech that sounds like it would be very applicable. Metal machining in the manufacturing field.
What about a 3D printing class?
Do you have those at your school?
Yeah, we got new things at my school up here in Northern. We have a 3D printer upstairs now.
Super cool. So they have a 3D printer now at Fort Huron School.
Northern.
Fort Huron Northern. Do any of you work with 3D printers?
We do in our senior design courses. That's more the mechanical, electrical, computer engineers that deal with that, and we have a slew of them in the lab. And it really advanced when they design. It'll be senior level class. They'll get some project to design and build a prototype to do something, and it just totally speeds up the ability to build that prototype because you don't have to go out and program the CNC machine and cut it and do all that. You can build all your little parts you need for your prototypes on the 3D printers. And so it's becoming, I mean, it's a tool now, it's not like a fancy thing.
We actually run 3D printed parts when we're doing our CNC tryouts, so we're, rather than having a metallic part in there, we crash into a plastic part and it doesn't, we're not perfect. Right, but we use 3D printed parts, we fixture them up in the machine and ship.
In one of my internships, I used a 3D printed part to get a feel for the size of where if it would fit in between two different parts. So it was 2 pallet dollies that were linking together, and I was designing a little hitch thing to connect them. So you could put them on the back of the forklift and just wheel these pallets full of really heavy parts to the other side of the factory. So using that kind of helped make sure it fit before someone actually went and cut the metal and welded it together.
So Austin and Lindsay, I know you each had really hands-on experiences through your internships in college. Would you like to start and tell about your experience?
Yeah, sure. So 3 years ago now, I interned my first internship at General Dynamics Land System. I had 2 there, so I was in their mass properties group. And I really didn't do a lot of engineering things when I was there. I kind of mass properties. So what you do is kind of take a weight of a vehicle and then kind of determine like center of gravities and moments of inertia, kind of basically give a weight and keep a bomb and all the information that's required.
Bombs and bill of materials.
Bill of materials, sorry. Yeah.
Engineer.
Not allowed.
Can you say that again?
BOM, bomb.
Bomb, so it's bill of materials.
materials.
So that's like all the parts on the vehicle, and then they have all the weights, and then they can kind of roll up and say this is what the final weight of the vehicle is. And that's important for military vehicles because they can get into 10 to 20 to 30,000 tons. So they're really heavy vehicles. Even I think the Abrams like 70 tons. So pretty heavy vehicles. But I got a lot of hands-on work, so I worked on the shop and helped weighing parts. So it doesn't sound too flashy, and at the time I was kind of like, this kind of sucks. I'm just sitting here weighing parts and working with mechanics. But looking back, it was really helpful because I got to kind of see how the environment works where they have a design and then you have to go building a prototype in the shop. So you kind of get to see all the different parts and how everything interacts together, as well as engineers make mistakes. They're not perfect, and how sometimes they think they're doing the right thing, but then when you see a mechanic who can barely fit one finger in a spot to try to loosen a bolt, you realize that you have to take into considerations that I never would have thought of before. So hearing them about their problems as well as talking to their engineers, you really can see how you have to kind of work together beforehand when building something.
Was that the one in German?
No, so that was here. So I also did a study abroad in Germany for 6 months. I studied abroad in Hamburg. It was my last semester, so I kind of had a slack off semester. It was really awesome. I really recommend anybody who has any interest in doing a study abroad, really do it. It broadens your horizons, and it allows you to meet different people and see the way they think, because every culture thinks differently. Just like German engineers are known for really being precise and perfect, and that kind of represented when I was working on a project with them. We were doing something, and we were trying to help invent a device to help pick up packages for drones. And they were so set on following this process. And they're like, we got to look at all these different ways of making this this package holder, and it's just, I forget the process name, but they were including ideas that didn't even make sense. And like, why are you even doing that? Why are you wasting the time? Like, well, this is the process, what we have to do, this is what we were taught. So for me, it's completely different. When I grew up and I took class, it's kind of more of a dynamic way of thinking. Like, you don't have to do everything like kind of on the fly is the way I think, but they were super regimented and rigid and had to follow this process, but I was a completely different mindset. So it kind of opened me up their side of view, and I thought sometimes maybe I was a little too gung-ho and kind of willy-nilly where I didn't follow the process. So it taught me to learn that maybe I need to follow the process a little bit more, but also stay true to how I operate, because everybody has their special way of learning.
What about you, Lindsay?
So I've had a couple different internships throughout my college years. My first internship was with a small company called Megline. So again, they were making pallet dollies and hand trucks and carts and stuff like that for moving around like Coke bottles or unloading chips from the back of a semi-truck into a party store. It was a really small company, so I learned a lot with the engineers there. I spent 6 weeks in the engineering program, getting to know like their CAD system, asking the engineers questions and stuff like that. And then I spent another 6 weeks in their quality department, so I was measuring like the diameter of some of the pipes that they would use, or checking the dimensions on some of the frames of the dollies that they had, just to make sure that everything was good there. And also checking parts once they came in from the suppliers, just to make sure that they were meeting the tolerances that the engineers were specifying. So then my second internship was with a company called CFTRW, which is out of Romeo. They make a lot of prototype safety systems, so seat belts, airbags, I think they do steering too, a little bit. But I was sewing these prototype airbags with industrial sewing machines, which they're kind of scary to work with actually, because they're really powerful and really fast. So I was going through these prints and making the airbags based off of those. So a lot of checking what the engineers were doing to make sure that they were understandable from the technician's point of view, which is really valuable to help give them some feedback, because like Austin said, sometimes you don't think about who's going to be making your design. So being on the end of the person actually putting everything together was a really good perspective. And then last summer I was at Ford Motor Company, so I was more in the office for that one. Ford's very, they're moving towards a lot of reusability right now. So I was making like a bushing library for control arms and taking all these bushings from different vehicle lines and all the different variations of those vehicles and putting them all into one place. I also got to go and do prototype vehicle checks. So I was in the suspension department, and after they would run these vehicles like on the proving grounds, I would go and make sure that the bolts weren't off their torque specs and yeah, checking all that over.
So how would a student go about, question?
It sounds like I'm going to say questions. How did you get referred to those internships?
Okay.
Like both of them.
I actually got a lot of my internships through the Society of Women Engineers. So my first one, we actually went on a plant tour at Megline, and the woman who gave us that tour was asking if any of us were looking for an internship. So as a second year student, you're not really thinking, what am I going to do for this summer or this semester? So I ended up applying to that and talking with her, and I still talk to her to this day, and we set up more tours to visit. For the one at TRW, my dad's friend actually worked there, and he told me about a career fair that they were having. So I went to that, and I ended up getting hired into their prototype department. And then with Ford, the Society of Women Engineers, they have a national conference every year in October, and that bounces around from city to city. So I went to that, and I talked to the career fair team there, and they interviewed me, and so that led to being hired in their internship. We also have a career services network, so that helps students get placed in internships, in co-ops and stuff like that. Our school is really big with Next Year and Dow, I think, because they're pretty close.
The career services, from our experience, and I'm sure everybody's doing this now because everybody knows what everybody else does, are very, very close. Probably half of what they do is your full-time job. The other half of what they do is internships. We're prepping you for that, getting you ready, working with companies to post on the internal online systems, ours called Handshake, internship positions. When we hold our career fairs in the spring and the fall, I think it was 300 companies this fall when we held it. There are for internships and full-time positions. So they're interviewing every company saying we have these internships, these full-time positions. So it's the most I'm sure the other schools are doing the same thing or doing the same stuff, has heavily built that into their career services. A lot of places are expecting internships. FCA right now won't that's a requirement for engineering positions. You know, let's say we have to have a mechanical or double E degree and in an internship, not necessarily with us, but you had to have had one engineering internship somewhere in your career. And I've known a couple of students who didn't, who FCA really wanted them, and so they graduated. They spent the summer on an internship so they could check that box off with HR, and in the fall start their full-time job. Just to check that box off. They're getting really serious about the internships. From your perspective, they're great because they give you the hands-on. They pay really well. They're great for your resume to give you the hands-on. And whatever you think an engineer does, you're wrong. You got to go out and do it and see what they really do. You think, oh, I'm going to be this kind of engineer, and that's going to be great. And you go in there and you get an internship doing that, you realize, oh, this isn't what I thought it was. And you look around and you deal with people and you feel like, you know, I want to be over there, not here. And that really helps. So then if we get that first job, it's not like, oops, this was the wrong choice. I should have picked that over there. It helps you to figure out where you want to be within. When we educate undergrads, we educate them in everything. Mechanical, electrical, industrial, whatever. And there's thousands of iterations of a mechanical engineer. I mean, you go to the FCA and look at two ends set next to another, completely different stuff. Thermal guy, he's a stress analysis guy, just doing completely different stuff. Going into the internships can help you see, oh, I thought I wanted this area, but I really want that area. And it can help you make that.
A lot of the companies too, like if you go to the Ford career site, and I know DTE Energy, you go to their career site and they say, I'm a professional or I'm a current student. And you go into the current student and they actually list all their internships and what the requirements are. You need to be a junior, you need to have this grade point, blah, blah, blah. So a lot of the larger companies actually have that posted on their career site. So, and that's the other thing. I highly encourage if somebody's thinking about working for a company or they have a dream, go out and research those companies in depth and understand what those companies are about and the things that they do and talk to people because, you know, and I use that example of the guy that recruiting brought in and they brought him in and he just wasn't happy doing what he was doing. It wasn't that he was incapable of doing the job, it wasn't the right fit. So try to make sure it's the right fit for you. And then, you know, Lindsay and Austin both described their internships and, you know, there's kind of a rite to passage, if you will. You're not going to go in there and design the, you know, next space shuttle or something like that. You're going to go in and you're going to weigh parts. You're going to get your hands dirty and you're going to understand how things work. Right, you're going to understand that stuff. Because that's what they want you to get out of those internships. They want that understanding. They want, you know, if you're working in an engine facility, they want you to know how to put an engine together. If you're working in a tank plant, they want you to know how to put the tank together because that's what makes you a better engineer, right? So you're not going to get the choice jobs of doing simulations and stuff like that. You're going to get coffee and you're going to get donuts and you're going to, you know, get your hands dirty. But it's you know, I think it's great to have the interns in. And then one more thing, and somebody mentioned the 3D printing, and one of the things that we're doing where I work at Ford right now, talk about the technology gaps. The people in this room, they understand 3D printing better than I do. They understand 3D scanning, and I was talking about this. So I work out of Romeo, and we've actually engaged the high school students. They're training our people in 3D scanning and 3D printing. So I got high school kids coming and training 50-year-old engineers on how to use the 3D printer and the 3D scanner and to convert 3D files over into 2D from a scan. So the technology that's in this room, the understanding of that far surpasses what I have. You know, Austin's talking about code. I mean, he's way far advanced than what I ever was at that age, right? And probably now. But that's the technology. That's where we're going. That's the gap. That's the gap that we need young engineers to come in and fill. And you get it from your robotics. You get it from your engineering courses. You get it from the stuff that you're out there doing as part of your high school curriculum today.
So with internships, as much as it's you learning about the company, you're also kind of interviewing them to see if it's a good fit for you. So when I worked at Ford, I wasn't sure if I was gonna like such a big global company. So I was just going with it and taking every opportunity that they had. So they do a lot of talks and stuff. So I would sign up to go to those and get a new perspective. Did you guys hear about the train station that they bought in Detroit? I actually got to go to there and walk around inside the train station through one of those opportunities that they gave me. So definitely have fun at your internships because it's a really important part to make sure you like where you work as well.
Now, you live far enough away too to where they put you in housing.
Oh, yeah.
So you got a really good gig.
Yeah, if you at Ford, if you live
More than 50
more
miles
than 50
long.
miles, like your housing resident and your school residence, they'll put you up in housing. So I was staying at the U of M Dearborn housing, and I worked 5 minutes. I was 5 minutes from where I worked, which is really cool. More snooze button.
Interviewing companies is really important in the internships. It shows you what's going on. Katie, one of our graduates from a few years back, interned at Forcia her first year. They do interiors of cars, tier 1 supplier, pretty good sized company. And kind of liked it, went to FCA, Fiat Chrysler Automobiles, major corporation, had a good internship there. Third internship went to a company called Caracoustics. Anybody heard of Caracoustics? Probably not. Small German company. They build acoustic materials for your car. So if you open up the hood on your car, you see that blanket under the hood that keeps the engine quiet. They will build that in the doors, over the roof line, under the floor, and the carpet. They build all this material that goes in. Very small company. Headquarters in Howell, the U.S. headquarters, so headquarters in Europe, and a couple plants in town. And she did her third internship there. And at the end, GM wanted her for a leadership development program. FCA wanted it in their manufacturing leadership development program. Caracoustics wanted her, and I talked to her about what she was going to do. She goes, I worked at the big companies. It was really cool. I did a lot of neat engineering. But at Caracoustics, I was working with the marketing people, and I got on their website, and I was working with the HR people. I was doing all these different things. I'm going with them. I'm going with this small company. They're paying less. I'm going with the small company. She went with them. They sent her off to Germany for 8 months to get training at their headquarters, and then back, and she's just having a ball doing all these different things. And so it gives you, jump around, do some internships. It helps you to make the right decision and figure out where you really want to be.
Remember that you're building your resume.
Yeah,
You're building your
resume.
network, you're building your resume, and it would be very important not to burn any bridges, even if you're not happy with the company. That's going to stick with you.
Yeah. The thing to remember is your life's that long, school is here, retirement's there, this is everything else. Make sure you pick that job so that when you start here, you're not saying, oh God, I can't wait till I retire. A lot of people fall in that trap, fall into what you want to do and love it. And it's, I'll be retiring soon, but I don't want to.
So I think this is a good opportunity to talk about a wonderful resource that every student in St. Clair County has access to, and it's called Career Cruising. Students, raise your hand if you've used Career Cruising. Every student in the room has used Career Cruising. That was a trick question. So, on Career Cruising, students will take part in an interest inventory. They'll identify their skills, their interests, and their abilities, and there's all these wonderful mathematical equations that help determine what potential careers might be a good fit for your son or daughter. So each of them should know their username and password. If not, I will be happy to look it up for you before you leave today. This would be a great way to have a conversation at home and continue this career exploration piece. I was going to show this at the end, but this is a good time to show it. Within Career Cruising, and students, I'll give you a break on this. You might not have heard of it yet, but there's something called My Bright Future. And that is our link. That is our link to local employers in the area, and you'll have the opportunity to ask them questions, to request internships, job shadows. You can watch videos of them being interviewed. So it would be like expanding our career panel to hundreds and hundreds of real engineers. Parents, students, you can learn about careers through Career Cruising. Let's say you were really interested in becoming a civil engineer. You can type it in here. You can spell it wrong. It'll still find it for you. Click on civil engineer. You can see earning ranges, how many years of college it takes. Like I said, career videos, people, real world experiences. This discussion board is where you're able to ask real employees questions. People have signed up to be coaches. Find out what your core tasks are, what attributes and abilities would go well for you in this career, what a day in the workplace is like. You can even, one of my favorite things, earnings. I don't know why this keeps happening. I'm just logging in as a student, sorry. Okay, so. This is where you would ask a career coach if you had a question. You could find related companies, so companies in the area that hire civil engineers. You can look based on location, industry.
We were talking before, Ms. Rochette, about certifications.
Yes.
So, and one of the certifications is to get your PE. Most civil engineers have their PE. So it's
Professional engineering degree.
Professional engineering, yeah.
If it's something after you graduated from an accredited engineering school, take the engineering and training test if you want to become a PE. And it tests you on the basics of your domain. And then you have to work a number of years.
I think it's 4.
And then do some certification stuff.
And then you can get.
And then you become a professional engineer.
So like civil engineers is an example to where if you're a civil engineer, most companies would require you to have a PE to be a civil engineer, or want you to get that because you're signing off on architecture of, structures and buildings and roads, and you get a stamp. You literally get a stamp, and you get your stamp. Or a lot of companies will pay for you to be the PE, and they use your stamp. So you would be the one certifying all the drawings for that company.
Anything you do officially with the government has to be certified by a professional engineer. Civil engineers, 90+% of everything they do is funded by the government. Who pays for the roads, who pays for the airports, who pays for it. So it's almost a requirement. Civil engineers all do it. You almost have to if you're going to work in civil engineering. In the other domains, it's a smaller percentage.
Yeah, but some of your smaller companies, like you were talking about,
They have to have one professional
They have to have
engineer.
one professional engineer on site.
Yeah.
So it's just something we
Kind of like
talked
a
about.
doctor signing off on.
Yeah, exactly.
Okay. So,
Yeah.
speaking of the government though, Austin, do you, in your position, need a security clearance?
No, I have kind of like a basic background check, but I mean, there are like you get security clearances like if you work on like classified information, like there's depending on like maybe it's just like the armor on the Abrams tank is classified. They don't know what it's like, so you have to have a top secret clearance to work on that. So I was in the process of getting one, but my boss I guess didn't find it necessary anymore, so I do not have one. But a guy, one of the new hires who's working with me, he's getting his at the moment. So depends what you work on. So.
Thank you. So just to point out a few other really useful things you can find on Career Cruising. I think that the Michigan Outlook is really important to take a look at, the percent of change in which civil engineers will be able to find a job by 2024, going up by 12%. Another great thing, you can find out if you'd make more money in a different state. We'll choose different states. You can watch real interviews. You can see a sample career path, different levels. Here's a professional engineer you mentioned, John.
Yeah.
And so it looks here, obviously, as you go up in levels, you go up in pay, responsibilities go up. There's related careers. I just think that this is such a useful tool for families to have these discussions. The education piece, you can search for schools that have these programs by checking and unchecking boxes here. You can compare schools. There's just so many wonderful things in career cruising.
Can I say something about schools?
Schools.
So I know he's from Oakland, but I am a huge proponent of dual enrollment and community colleges. I'm just letting you know that now. And here's why. If they would have thrown me into a university right away, I wouldn't have made it, right? I needed that smaller class size. I needed to feel more comfortable in that classroom environment. I couldn't have afforded to go for another one, right? So the community colleges, and if you play your cards right in a community college and you have that upfront discussion with a counselor and you say, I want to go to Oakland, I want to go to Saginaw, I want to go to Michigan, these are the 3 schools, and you make yourself a little Excel sheet and you make sure everything you're going to take is going to transfer to those 3 schools. I'm just a huge proponent of it, because you could, parents or kids, if you're paying for it yourselves, you can waste a lot of money on education and you're not going to get anything for it. So dual enrollments out there, there is a lot of flexibility in dual enrollment that that you can utilize and get that, right? When you have that opportunity, please take advantage of it, right? Especially with the dual enrollment. I mean, you can have almost a 2-year degree by the time you're done if you really want to work your tail off.
And we have a few new options too, since your boys have gone through with we have a career and technical middle college now that is connected with our tech program, and we have the Blue Water Middle College for some of the schools in the county. There are many credit earning options, free credit earning options within high school. AP classes at the end of the year. Austin, you mentioned you took some AP classes. And taking the SAT seriously, the test that you're going to take as an 11th grader, that not only gets you into college, it gets you money for college, and it places you into classes for college. Do you have something to add, Lindsay? I think you had a really great school counselor that may have pushed you towards dual enrollment.
Yeah, I dual enrolled in high school. So when I started dual enrolling, I still wanted to be a pediatrician, so I was taking like anatomy and physiology classes, which didn't really help me out in my degree. But the credits transferred, and some of the things you might not think about is that seniors get to register for classes first. So then it goes from highest amount of credits to the lower amount of credits. So as a freshman, if you're registering for this class that you need and it's already filled up, there's nothing you can do. But if you're coming in with some credits, you might be able to get into that class, even though it would be for higher level classes. Yeah, because sometimes seniors retake classes to get better GPA scores. So if they register first and then they're taking your spot, you gotta make sure that you're gonna be taking your classes to stay on track. Yeah.
Yes.
Speaking of schools and where to go and 4 versus 2, isolating down to a few colleges that you want, knowing that they have the program emphasis in that area. Does it matter which one? Tech versus Oakland or Albion versus,
So,
like there?
I actually had that debate when I was going into school. So all of my tours that I went on, I was looking at the people there, the school size, how big the campus was, if you can make it to 5 minutes to class because you had snoozed too much. So I was interested in the biomedical program at Michigan Tech, and I got accepted to that. Saginaw Valley only has electrical and mechanical engineering right now. Because of my ACT scores and my GPA, I got a full ride scholarship to Saginaw Valley. So that was my deciding factor. Scholarships can play a big role, but I think finding a good fit for yourself and what you want to do with your degree. If you want mechanical engineering, is very broad. You can go into pretty much anything, but if you want to get the specific biomedical, then you'd have to go to there. But I don't think it's super necessary to have the exact degree because you get a lot of training once you get into your job as well.
From a hiring perspective, it doesn't, at least from my perspective, I mean, I see applicants all day and I don't look and say, oh, they went to Michigan or they went to Michigan Tech. 4-year degree, BSME, BSE, whatever they have is.
Can you Say that again louder, because that's really important.
So I don't really look at the college. I mean, I deal with recruiting all the time, and it's, you know, it doesn't matter to me if you went to Oakland or you went to the University of Michigan. If you made it through an accredited engineering school, good for you. That's good enough for me, right? I mean, I don't really look at that. Here's what I do look at though, and I heard somebody mention it earlier. And not that if I get a brand new young engineer that comes out of a college, there are some programs that have an engineering technology degree, and it's a 4-year degree, but basically all they do is skip all the math. So if I have 2 applicants there and I have one that has the engineering technology degree, I know Central's got one, Ferris has got one, do you guys?
Western, we don't have,
Western,
Wayne State does.
Wayne State has one. If I look at that and I see BSET or BSMT, right? It's a technology degree. It's not a true engineering degree, and I would take applicant that had the true engineering degree over the technology degree. And the reason for that is because they didn't take the math. Not saying they're any better or any worse. There's a lot more hands-on to those technology degrees. That's a bonus. It all depends on what I'm looking for. I just hired a Central Michigan engineering technology degree grad last summer, and he's great, but he's doing a hands-on job, and that's what we wanted him to do. To where I just hired another guy that I needed to be more analytical, more into the problem-solving side of things. I couldn't go, and I had applicants that had the technology degree, and I had to go with somebody that had that full engineering degree.
The engineering degree does keep your career broader and more open. Again, I will get people coming back to our master's programs with technology degrees, saying, hey, can I go in your master's program to get an engineering degree? And well, you have to have an engineering undergrad, but let me see your transcripts, and oh yeah, you got a lot of good stuff here, so go back to community college and take 3 calculus courses, and maybe take a stats course there, and then take our 3 junior level engineering courses. And your degree plus all that stuff will get you into our master's program. And they say, okay, great, GM wants to promote me. I'm a level 6, they won't let me go to level 7 unless I have an engineering degree. This doesn't count. And so we have probably 30 people in my program in various stages of doing that right now because, you know, when I went to school, I thought I didn't really want to do the math, and the technology really is good enough, and now my career is being stymied because they simply want the engineering degree. It opens doors, it gives you the ability to go different ways. You can have a great career with engineering technology.
And it is a 4-year degree. They'll tell you at these colleges, it's a 4-year degree. They'll tell you at Ferris and Central, it's a bachelor's degree, but it's in engineering technology. It's so.
There are job postings specifically for engineering technology, and you can see that there's a difference in their pay scale too.
It's a different pay scale. It's a different job, a different career. I mean, that may be for you. But understand what you're getting into. Don't think, if anybody says, oh, it's just like engineering, it's not. The companies know the difference.
Right.
And they will treat it differently.
So I know you've mentioned calculus, but what really specific kinds of math do you guys use? And I guess even more specifically, how often do you guys use derivatives? That's what we're learning in IB math right now.
Calc 1, derivatives.
Yeah.
That's the very first calculus course.
So can I say something about the math? Because you use math all the time, right? I don't use math, but what the math teaches you is it teaches you systematic thinking. So when you're solving those problems and you're doing those problems that are 4 pages long and you got a pile of eraser shavings that are that high on your kitchen table, it's teaching you the systematic thinking in order to do it. It's not that we use derivatives every day or we integrate stuff. We don't do that. I mean, we'll get out an equation and figure out the flame speed across something or whatever, or heat transfer. We'll do that using the equations, but it's not like you're deriving, you know, the Taylor series and going through. You're not doing a Taylor series expansion yet.
What type of engineering would?
Some will get technical, a lot won't.
Minors in math.
I mean, it's like your phonics when you were a kid. Noun, verb, noun, you learned adjectives and all that stuff, and now you speak and you do all that stuff, and it's not like you're analyzing all that. It's becomes second nature, and it becomes a second nature tool for you that you use in a lot of the analysis. And a lot of times you say, oh, I never use math as my career as an engineer. You run into engineers who'll say that, you know. talk, what do they do? And it's like, no, you're using it all over the place. You're just not kind of doing it the same way as when you learned it. It's part of your thought process and part of your problem solving processes.
If you ever ask an engineer for directions to get someplace, they're very descriptive and they go step by step in the description on how to get from point A to point B. And that stuff is drilled into your math classes that you're taking, where you're going down step by step by step by step. They're systematic thinkers and deductors, right?
That said, if you're really good at math, there are a lot of engineering jobs that are very mathematical focused. I mean, in my domain, calculus is big, but we're probably even bigger than the statistics side.
Yep.
Because a lot of our systems are too complex for differential equations to define because of the random behaviors. And there's a lot of heavy-duty things you can do in the calculus side if you're an operations research, which is a big U of M area, or in the statistical analysis, if that's where you want to be. And engineers that just are second nature at math, it's a smaller subgroup, but they get companies start those guys right up because there's always, we need these people to really do the heavy-duty analysis. So those jobs are out there.
They are out there.
They are out there.
If you like math, I mean, there's plenty of opportunities to utilize.
Did your question get answered?
Well, this is a statement. I know when I was taking classes at college, I signed up for, I was on fair. I ended up doing my courses on the SCCRESA campus, but I took advantage of what was called the macro stamp.
Yep.
Where there was a lot of classes that you had taken, and some classes you went to take from the university.
Yep.
Exposed all that too. But also, I went in as a consortium student, so I was signed on as Ferris, but taking classes at SE4, which is at the, which transferred over.
Yeah.
Ferris is paying for the class.
There's still some opportunity to do that. The community colleges and the universities and such have something called the Michigan Transfer Agreement now, very similar
to transfer
macro.
72 credits, which is some people.
Yeah, so there's plenty of opportunity to take community college classes and transfer to a university 4 years. Okay, any other,
So currently my daughter's been involved in some like safety preparedness things. And so one of trying to like what kind of things could you do with that. And one of the things that came up was like a occupational health and safety, which when we researched that a little bit, I was surprised because it fell under a lot under the engineering.
Right.
Can you, and I think Oakland and stuff too had some programs, can you kind of like help kind of put that together, like the types of things maybe you'd be doing in that area?
That area, it broadens from the technician side to the hardcore engineering side. So we do have a program, it used to be called occupational safety, now I think it's called environmental health and safety. It changes things. That is outside of the School of Engineering. It's more on the technical side. So you're not getting an engineering degree. They don't call it a technical degree, but it's more that way. So it's a little more hands-on, more of the technical stuff. Within industrial engineering, because we tend to design manufacturing systems, our domain of engineering is considered the people side of engineering because the system has people in it. I mean, pieces of the system are people. I got to design a manufacturing system and there's 20 workers on this line and they're all doing these jobs. Okay, well I got to make sure that they don't get hurt doing those jobs, that they can keep up with the pace. Am I overstraining them? That's going to affect quality and production because they're working too hard. Can they complete their jobs at a good pace and not overtly hurt themselves? The force they're applying, that somebody might pull muscles. Or more importantly, they do that over and over again. Like I started seeing carpal tunnel and bad backs and things. So that all tends to fall into the domain of industrial engineering. We call it ergonomics and human factors. And so we require our students to take ergonomics course. That's one of the required courses, that one of the many things you will learn. The students who like to specialize in that will go on to take our human factors course. We have we use a Industry 4.0 tool called Jack to do ergonomic analysis. It looks kind of like The Sims. You put little people in and move them around and have them pick up and move stuff. And while they're doing this, it's measuring the stresses on all your joints. And so you can do a complete analysis of that and say, yeah, the person could do this, But, you know, they do this 8 hours a day, 48 weeks a year, you're gonna start seeing carpal tunnel and you're gonna start seeing those kind of issues. So you can get into this application domain within industrial engineering. It's a domain of industrial engineering. It's the human factors is more the mental interactions. How do I interact with the computer program? How do I set that up to work better? Your phone, how do I work with my phone? You've been in cars where you wanted to set your heater and like just reach over and set it. In other cars, it's like, oh, open the screen, open it. You're like, how do I do this? That's bad human factors design. So it's getting more on the psychological side with the physical side.
There's a certification that goes along
you
with
can
that.
certify in that?
So what you're, so you can, it'd be a CSP, so you could go get your engineering degree in industrial and systems engineering and then become a CSP, which is a certified safety professional. And that's another certification to go in and get. So we have our safety engineer in our plant, and we have them at every single plant, she has her degree in industrial engineering and she's a certified safety professional.
So would that fall more into the statistics side?
Well, the math you use there tends to be more statistics.
Calculus scares the bejeepers out of me.
Calculus, at ABET accreditation, 4 years calculus, you can't, if you want to be in an ABET accredited program and you want to be in an ABET accredited program, it's 4 years calculus. There's just no way around it. It's just what they make us do.
A lot of schools have tutoring centers that will cover all of 3 years of math, so you can spend an hour every day and they'll help you go through your homework and prepare for tests and
A
stuff
hint?
like that.
She does well.
A hint?
Great.
Yeah.
I shouldn't
But
say this.
it falls into that, I don't know if I want to do this for 40 years.
Well, you know, you do it just for 4 classes. Take your calculus at community college. They do a really good job teaching calculus, whereas the university, I hate to say it because I'm a university, you were a university, they tend to get a little bit more theoretical, whereas the community colleges tend to be a little more application focused on their math and you know, how do you do and use it versus what are the roots of why the equation looks that way. You know, they're improved.
Unfortunately, you can only get, unfortunately, you can usually only get 2 of your 4 years out of the way to the community college.
You can do 2, yeah, and the key is you got to, like John said, you got to be really careful to take courses that transfer because it's very easy to go to community college and take all these courses and then find out, ooh, half of these don't apply. I mean, the university won't take them for anything. Engineering is a very strict 4-year program, and if you won't get some university, the general advisors will come in, people will come in and talk to the general people, not the engineering advisors, and say, I think I'd be an engineer, and they'll say, oh, no, go try some other courses and do some stuff your first year, and figure out what you want to do. And so they'll take a couple engineering courses in the engineering track in math, they'll take a couple other things, and they get to the end of the first year, and I'm going to transfer to engineering, and then they'll say, oh, you know, half those courses you took, they don't count. You should have been doing and these things don't count because an engineering degree is packed 4 years. There's not a variation.
If you're dual enrolled now and you're interested in doing it or you're taking classes at community college, pick out 4 schools. I had Wayne, I had UAD Mercy, U of M Ann Arbor, U of M Flint, and I had these schools and I put them all at the top and I put down all the classes that they had available and then I put an X in the box if they transferred or not. And I checked with that counselor every single semester at community college to make sure those classes were transferred.
Yeah.
Every single semester I was in there. First name basis, hey, here's where I'm at. And then it came to the point to where I could still take more classes at community college before I transferred to U of M to do it. But I carried that sheet around with me for quite a while and kept track of the classes there.
As the SC4 has that, I know at least we did that with the Sundays, look for open, I don't know, but that Michigan transfer agreement or whatever, that is very helpful because they just plug in the computer at SC4 and they say, okay, I'm at SC4 and I want to go open for physical therapy. That's what he's done at the time, and it just told him so that his dual enrollment classes, he made sure that they were going to transfer.
Yeah.
I assume you can just probably go back in and.
Yeah, so who can think of somebody in your high school that could help you with this? For kids. Who in your high school could help you?
Counselor.
Yeah! All right. Good answer.
Good luck.
Also want to bring to your attention that universities and community colleges will talk to you even though you're in high school. So any admissions office is more than welcome to help a student of any age start planning for their future. They love it.
Your question on the ranking stuff, it's not as important in engineering, but the bigger, more well-named schools will open you to more opportunities a little bit, just because they're bigger and more well-known. Michigan, MIT, Purdue, those kind of places, the Michigan States and the MIT, RMQs and stuff. You will get opportunities anywhere you go, just because that's the way engineering is, no matter what, you can go everywhere. They'll say, is it A better credit? Make sure you do that. Probably the most important thing, though, is find out the culture. Visit the school, find out the culture.
Yeah.
Is this for me? The bigger schools tend to be bigger. I mean, the smaller schools, you have closer contact with faculties, with smaller class sizes. It's just, find the culture that fits you, because that can make a huge difference.
In career cruising, there is the opportunity to compare schools. You can see how many students per class size, how the faculty to student ratio. For example, at Michigan State, I had 635 people in one of my first classes as a freshman. Austin had 500.
Yeah.
I believe 500 kids wanted to go to
Oh,
that.
geez.
I know, right? Yeah, I know.
You know, they had to have 4 in
My
each
largest class is 70
because there was
students.
6,000 of them.
We do have a sophomore class of 70. After that, they go to about 30.
So Lindsay's got something to show us up here on the board. I'll get out of the way.
I don't know if all schools have this. I'm assuming there's probably something similar. But if you go to the SBSU website, you can look up the engineering flowchart, and the electrical department has it too. But it'll give you all of the class names that you'll be taking throughout your semesters there. Yeah, some of these lines are like 20-something credits, so it's like not really doable unless you want to not sleep or anything. But
Or hit a snooze button.
yeah, no snooze if you take 20 credits.
So if I can't follow all these arrows, should I not go into engineering?
Oh, the arrows are actually, they're not bad.
She's an engineer.
The solid ones are ones that you have to take. They're the prerequisites. So the gray ones, I believe, are prereqs for the 300 level classes, and then the darker ones are prereqs for the 400 level. But these ones up here, you can use that to search in the Michigan Transfer website to see if they'll transfer for you, because you need to know the course name.
How come some of the boxes don't have any arrows on them? Look at the first box of 5.
This is a gen ed class.
First
Those are
year,
freshmen.
those are first year
Yep,
courses.
so this is your first one. So this is a gen ed class. It'd be like a speech class, something that you could transfer. I transferred that one from SCCRESA while dual enrolling. So you could take that any semester you wanted, really. And then these dashed lines are classes that you can take at the same time as each other. Yeah, so.
When I started here, there was, they considered it called the Bible, in the catalog. So when I started my program, I was locked in to what those classes were. So I started in 2009. So if they added a class in 2010, I was not bound for that class because I started on the catalog year of 2009. So anything they started years on one, I didn't get, and I was just given those credits for those classes. I was within locked in.
Yeah.
So you guys gotta pay attention to.
Yeah.
The catalog is a legal contract,
Yeah.
and so when you start university, you will be under a catalog. Usually it's an academic catalog, September through the following September. So let's say you start in the fall of 18. The catalog that's active at that point in time will list these are the program requirements. And those are your program requirements. And so when the next catalog comes out and it changes, you're under your catalog. Now what you can always do, if you look at the new catalog and say, I like this program better than mine, this is nicer, it has things I don't have, you can always jump to the current catalog. They will always let you do that, but they won't change horses in midstream. You are bound by your catalog. If something gets eliminated in your catalog, I've never run into this, but I've heard it can happen, like here's this course I have to take and we don't teach that anymore, they will give you they'll say, okay, here's the equipment, we'll take that and we'll cover for that. But you're bound by the catalog when you start your
Yeah,
program.
because you end up paying more money if you don't. I followed my own road, I was my own counselor.
So I want to make sure that I allow enough time at the end for you to meet with the panelists individually if you have specific questions. But one really important question I'd like to hear all of you answer is what you love about your job. Help us understand that. Austin, do you want to start?
Okay, so I guess kind of one thing I love about my job is I have a lot of freedom. So I kind of came in, I was a new guy, and I did a pretty good job. So they kind of gained respect and knowing that I would get the job done. Or if I had questions, I go ask people and not kind of be stuck and struggling. I think that's a big thing, is learning to accept that you sometimes don't know something and ask the people who know what they're doing and ask those relevant questions because they're willing and eager to help. That's what I've learned. But like I said, I just love the freedom. I get to show up and kind of do what I want. Not in a sense, I mean, I get a project, but like a couple days ago, I started working on picking out sensors for this vehicle, and then I made a schedule yesterday, and then today I worked on coding for the drone. So right now, me and this other guy, a new hire, we're taking a code software called Unity. Basically, it makes video games. So Unity is the Fortnite engine. You guys know all heard of Fortnite. So that's the engine that Fortnite runs off of. So right now we're playing in Unity. So we're coding in there, trying to plot an autonomous mission for our drone. So basically, what we're going to do is have a drone that can attack a target. So with a payload, so fly up, and there's bombs attached to it, and then it'll hit a target and eliminate the target. So the plan is we're going to simulate this flight path in 3D in this gaming environment, so we can kind of say, hey, if we change different variables or change the way the drone's flying, we can see it as it's going to be represented in the real world, so then we can take that and then transfer that information over to the drone and then do simulations and we fly it outside. So I have a lot of freedom, which is really nice.
Thank you.
Getting to work with everybody, with people. I work with students, faculty, people at companies, and we kind of all work together to try to take these students out of high school and turn them into professional engineers. It's a lot of fun dealing with everybody. It's a big mix. We're trying to build, in our program, we're trying to build this culture of everybody works together and not just, you guys show up in classes and then go out and get a job. It's watching the students grow. We have about a third of our students at Oakland University in engineering are first time in college for their family. They're the first person in their family to go to college. So we got a lot of people who are, moving into a whole different domain, a different way of life from what their parents did. And it's a lot of fun dealing with that and helping people out and putting together programs that make a difference.
I like getting to learn new things every day because right now I'm in a place where I'm not doing specialized things. I'm doing the same thing every day. So I'm dipping my toes into thermodynamics and vibrations and machine design. So I get to see a whole bunch of different elements of engineering that might be interesting careers.
I think I like the best is when you're facing a problem and you can bring a team of people together and, face something that nobody can solve and come together and solve it. I think solving problems from which there appears to be no answer is the engineer's biggest challenge in his whole career. That's what they want to do is solve stuff, and that's probably what and dealing with people, right? I like dealing with people.
The fact that all through school there was an answer, and now there's no longer an answer, but it has to work, so we've got to come up with something that does work.
To make something work.
In fact, there's multiple answers and which one's right and how we figure that.
My wife hates living with me too, by the way.
She does, she told me that.
Yeah. There's always an answer to a problem.
So hopefully some of those reasons that these guys love their jobs resonates with you, and you can start narrowing in on your future and your plans for the future. Like I mentioned, a wonderful tool to do that is career cruising. If at the end of the night you'd like to know your son or daughter's username and password, I'd be happy to give it to them, and then you can force them to show you their educational development plans that they've developed through their years in school. Our students start working on it in 7th or 8th grade, so by the time they're a senior, they've had exposure to this for at least 4 years. Some other ways to continue your career exploration would be to continue coming to our career panels. So next month we're showcasing information technology. There's a huge overlap, we heard, with this sort of thing in engineering. There's also a huge need for information technology skilled workers in our area. In January, we'll jump into health careers. February is specifically for 11th and 12th graders who want to learn more about money for college, whether it be federal, state, or local funding, scholarships, filling out the FAFSA. And then in March, we'll investigate criminal justice careers. See what I did there? Investigate. Thank you. And in April, we'll get back into energy and environmental careers. So hopefully, you picked up a flyer on the table over there that has all these events listed for you. This is my information. If you need it, I will be here to answer questions when we break into smaller groups. Any questions before?
Well, that specific questions to each of the groups.
Yep. We're gonna give 10 to 15 minutes in smaller groups. I'll just ask the panelists to kind of spread out around the room and answer specific questions then. Yeah.
Do you guys ever get tired of working with people?
Every single day.
Thank you for your honesty,
Every
Mr.
single
Francis.
day.
Yes.
Talking at me all night. You mentioned robotics. There's the means to the end. You build this little thing and it goes out and you can either battle or whatever its purpose is. But just in general, it's a good avenue for an engineer's mind because it has multiple aspects of engineering. Do you agree?
You know what the most important one I think is in your robotics team? The team. Because here's the thing, right? I've worked with some unbelievable engineers over the years. I mean, some of the most well-educated engineers in the world, and some of them are so socially inept, it's like talking to a chair. Seriously, I mean, that's what they've done, right? And so it really, all kidding aside, folks, that it narrows your career path down significantly. So you might be that person that wants to sit there and work on the computer and do that. You've got to be able to communicate with the people, and that's what I think is important. I've mentored several robotics teams in the last few years, and the best thing that I see about that is watching those young people come together, and first they'll storming, norming, conforming, right? First they're fighting with one another, and then they're getting along with one another, and then they build this great thing within hours and days that I don't know how in the heck it's going to work, but it always seems to, and that's I think the best thing is learning how to work with others in that robotics. Not to mention the coding stuff I glaze over.
If you're absolutely brilliant in living in your own little world, you're no value to the company. You can't communicate with others and get your solutions to them and understand their problems back and forth. Your value is, wow, you're doing brilliant stuff, but they have no value for us. You have no value for that company. And the communications is where you deliver your value.
It also teaches you really creative solutions. That class that I was taking, we almost had to scrap our entire robot 4 hours before the competition, but we ended up being able to fix the problem with a rubber band. So yeah, you get to do some really creative stuff.
Also, I would say nothing's ever finished. You don't ever just stop. It's always, even if you have the robot, well, what can you do next? That's kind of what it's this iterative design process where we build this vehicle, but now what does the military want next? So there's always this iterative design process, and at least in the defense contractor world, we always the government give us requirements, and we kind of go build those specifications. But now it's coming more of like the automotive world, where you have to kind of go invent stuff and say, hey, this is what we can do for you. Like how, like a brand new vehicle, they have, well, this is what they have in the car, or they have advanced braking, or what have you not. Just like the latest and greatest, and so that's kind of what our government contract is going to as well. You kind of almost have to beat what they're going to ask you, so you can say, hey, we already have this for you, just come buy it from us right now. Kind of a never-ending learning.
Lindsay, could I ask you to do the honor to drawing a lucky?
Oh, wow. And the winner is Lindsay.
She said, "Can I pull my own?"
Ryan Cunningham from Memphis Junior Senior High.
Great.
Great
job.
drive safe. Thank you so much for being here. Come again next month. We'd love to see you again. Right? Get twice in a row and you won.